Yeah, let's start. Good evening, everyone. So today we are discussing the non-parametric counterpart of t-test. And I've already told you, parametric tests are the tests which you assume that the distribution of the variable follow a theoretical distribution, which is a normal distribution, and some other condition like homogeneity of variance. So if those important conditions are not met, or when or not all the conditions of using a parametric test are met, you can decide to say, okay, you have three options in order of importance. Say the first one is to use a robust test. If you maybe you look at the test that is you consider it to be a robust test, like t-test and over, they are robust tests. A robust test is a test which is still valid, even when not all the requirements for using parametric tests are met. So the second option, if you don't want to use a robust test, you can use the non-parametric counterpart. In that situation, you don't need to assume that it follows normal distribution. And the third option is what you should not even do at all, is to transform the variable and now use a parametric test. Okay, let's look at, we have discussed three types of a t-test yesterday. The one sample t-test, the independent sample t-test, and the paired sample t-test. So all this, each of them has a non-parametric counterpart. That is, if the conditions are not met for using them, you now use this non-parametric counterpart. So sometimes data sets do not meet a assumption required for parametric test to be carried out, and it is not possible to correct for the problem of the distribution through transformation of the data or to use a robust test. In this scenario, we can use special kinds of statistical procedure known as non-parametric tests. They are sometimes known as assumption-free tests. We can call them assumption-free. And because we make fewer assumptions about the type of data to which they are to be used, on which they are to be used. So that's why it's an assumption-free test. Most of non-parametric tests work on the principle of ranking. It's ranking. You rank something from ascending order. It's based on ranking. So I find the lowest score, giving it a rank 1, and find the next higher score and give rank 2. So on. This process results in high score being represented by high rank, as you see, while low score being represented by low rank. So the analysis is carried out on the rank rather than actual data. So in non-parametric tests, instead of if it is parametric test now, you calculate the mean, average mean from each group. But this one now, you rather calculate, you don't the mean. You don't use the mean, you use the rank. So you don't even use the actual value, it's the rank to use to make your judgment. So look at this table is showing you the scenarios, the t-test and their non-parametric counterpart, which I've already even shown you before. So for the number one now, compare a sample mean with a population mean. The first one we did yesterday. So one sample t-test you use, it's a parametric test. The non-parametric counterpart are Wilkinson sign rank test or sign test. Then to compare means of two independent group, the parametric test used is t-test use independent sample t-test, or commonly known as student t-test. So the non-parametric counterparts are Wilkinson ransom test, Mann-Whitney test, Kendall test, median test. All of them. But to be sincere with you, is this Mann-Whitney you they usually use. They can use Wilkinson ransom test, but it's in fact the issue there that Mann-Whitney is improvement on Wilkinson ransom test. That is gone further. That's why people prefer to use Mann-Whitney because it has gone further than just using the ranking. Then tell the mean of the difference in peer observation. You know, like the last one we did yesterday, which is pair sample t-test or pair t-test or dependent t-test. So the non-parametric counterpart is Wilkinson sign rank test and sign test. Now, you will see that Wilkinson for two independent groups, Wilkinson rank sum test. Both of them have rank, but the other one pair Wilkinson sign rank test. Sign. So there's sign. When you say sign, here now you get to know later the sign they are talking about is a positive sign. So let's just give some historical background. Wilkinson test, the first developed by Frank Wilkinson. This Frank Wilkinson, you see the picture, an American chemist in the year 1945. That was the first to develop and describe this test. Henry Mann and Donald Whitney in 1947. Those one, when we talk about Mann-Whitney, Henry Mann, and I think their picture is in our process. Then we have polarized by Sidney Seget. You know, I told you that the Henry Mann and Donald Whitney, the work that Mann-Whitney is a further improvement on Wilkinson test. So after Wilkinson 45, these two other people work on that test to make it a robust, better one. Then popularized by Sidney Seget, 1956, the one that make it popular. This man and Henning Barthold Mann and Rona Ransom Whitney. That's how they call him Mann-Whitney you. So there are two of them. So it's not one man do the description. So let's come back to the work. So comparing one sample with a population parameter. In a situation, let's now say, you know the counterpart of one sample t-test now. So the non-parametric counterpart for these are sign test, the type of median test, Wilkinson sign rank test. Yeah, sign so sign test use only directional information. Just say, you know, directional information, with direction positive, negative. The Wilkinson test uses both direction and magnitude of information. So magnitude means it's able to at least give number, but the other one does not give number. It's directional. Does the Wilkinson test more powerful statistically? So let's start with this first one. One sample Wilkinson sign rank test. One sample. So that's what they actually call sign test. In a law college, this is a question. In a law college, a random sample of 10 student mark is noted below. Look at it. 10 students. You know, the upper row is the blue one, just to tell you the identity of the student. Number 1, number 2, number 3 to 10. Yeah, they mark the score. Is this so is there evidence at the 95% confidence level to suggest that the median the median mark is greater than 67. Maybe they already said that before, for that class, usually you see around 76, 67. So here now, you can see people have 71, 79, 40, 17. So is there anything to suggest that this median mark is greater than 67? So the step in solving this, in computing Wilkinson statistics, calculate the difference. The difference between each of them. They're ignoring the sign. Rank the different smaller rank 1, smallest from 1 to the end. Like for this, it's going to be from 1 to 10. So, when you do the difference now, some will be positive, some will be negative. You have already said, you say that there's a suggestion that the median is greater. Is there evidence? The median is greater. So when you want to do that, you want to remove the 67 from the value. So separate the positive and negative rank. So let's see the way it goes. How you compute it. So look at the first table up here. We now look at the difference. You remove 67 from each of them. Look at what you have. At least you have one that is negative. But two self. There are two of them that are negative. They are negative value. Minus 27 and minus 7. Because those are the values that are less than 67. Now, the next table, the one in the middle. So for you have another row now. After you have ranked, you see the difference. You list the difference. You now look at it. You now give the rank, irrespective of the sign. The meaning of the rank is that the smallest will be given 1. If you look at 2 is the smallest, second is like 2 is the smallest, so 1. Followed by 3, give it 2. Followed by 4, you give it 3. Followed by 5, you give it 4. Followed by 7, you give it 5. You don't consider the sign. Followed by 8, you give it 6. Followed by 9, you give it 7. Followed by 12, you give it 8. Followed by 15, you give it 9. And the last one is 27, the highest. Even though it has negative rank, but you ignore the rank. You give it 10. Now, what you now do now, the last is, what we should not separate them. The one that are from the rank that are from the positive and the rank that are from the negative. Can you see now? Sorry. That's what you just did. So you now, if you sum them, you're going to see that if you sum all of them together, the sum, the one that are positive, the total 40. The one that negative, they are 15. The rank from negative 15. So smallest value between 14 and 15 is 15. So the statistic is 15. So the statistic is 15. Can you see now? It's just the small, that's why I say directional. The smallest value. So it's 15. So interpretation now. Since test statistic value is greater than the critical value, hence I said so there's no significant evidence that the median rank is greater than 67. So I want to send a note of warning here. If you notice all the statistics, hypothesis tests, they are end in p-value. As the value increases, the more likely they will be significant. Because as the value increases, the p-value decreases. You move in opposite direction. For example, now, t-test as the t, if you are talking about error t-test, as the value increases, is more likely to cross the be greater than the critical value. So as the value increases, the possibility of it being significant. The same thing with chi-square, nova, all those things. But for this Wilkinson, remind to you, this non-parametric counterpart is the opposite direction. So what it means is that both the statistics value itself and the p-value move in the same direction, not in opposite direction. So as the statistic decreases now, the p-value decreases. And you know that when the p-value decreases, it's more likely to be significant. So the critical value for the degree of freedom here, for the 10, that is sample of 10, is 11. So if, let's say, we have the calculator is less than 11, maybe the smallest value is like 8, 9, or 10, we say significant. Any question? So let's run it. So we'll do it and run it. Any question before we run? Any question? No, that video people refuse to come now. It's like those people that can share. Yes? Somebody wanted to ask question. Somebody wanted to ask question. Oh, who is sharing on? Dr. Miller, welcome. Who is sharing? Mark, there is one, they call him Mark. That's the name of the file. Glory, ATBJ, share. The file name is Mark. As called. Glory. If you are talking, you have to move. Glory. So you think that you are hearing me now? So who is here? Samira. Samira.
Yes, sir.
Let me try.
So you don't want to share, or you see a problem with your system? Okay, who say you want to try?
Yes.
You are not saying anything now. You say yes, you say yeah. You are muted. Who say, is he Mokhtar?
Yes,
Is it Mokhtar that say one or Farouk?
No, it's Mukhtar.
Okay, let's see. It's Mark. The name of the folder or the file is Mark. Thank you. Yes. Scroll through. You have not scrolled through. Scroll through the end. You can see Max is there in the middle. Yes. You have to share it as column. Yeah. So you can see the arrangement now. You have the serial number for the 10 of them. You have the median score, 67. You have the mark. If you look at it, because they are called the test score, the one they say, the median one, the one they give us. You now write it in each cell for everyone. Can you see now? You write that 67 when you are entering in. You see all of them are 67. Then the mark, the mark you are testing at the other one. Very straightforward. So go to analyze. Go to analyze. So you go to non-parametric test. Down. Non-parametric test. And you go to legacy dialog. Legacy dialog. You have to do one sample. It's one sample. No, it's
This
not.
one?
No, it's not one sample. It's related. They use them as related. K related sample. K related sample.
This
Wait.
one,
No,
two related
press on
samples.
that. Wait. Press on that first one first. Let me see. Because it's like you can even that first one. Press on it. Let me see. Because
The one sample.
let me see what it brings out for you. Okay, move. Let's see. Move that median. No, it's not median. Mark. No. It's mark. No, return it. It's mark you are putting there. Move mark there. This uniform, let's see. Okay, just log off, go back. Just go back. Cancel. Just go to the other one. It's for something else. Yeah, go to legacy, non-parametric, legacy dialog. No, you are not there. Non-parametric. Legacy dialog. And then K related is related. I'm coming. Case independent. K is two related. No, it's not. Okay, no, two related sample. Two related sample.
Oh, this one.
So move. First of all, move the mark. Then move the. Click on the median and move it. Then you can click on sign. You say we can do sign test also. Click on the sign also, apart from the Wilkinson. Yeah, click OK. So you have to show us your view, your result view.
Okay.
Go to window now. Go to window. Go to window up. Look beside help. We cannot see. Okay, you cannot see the result here. Don't worry. You can log out and now reshare. If you go to window now, you now click on the viewer. We will see it. But you can log out, stop sharing, and share again. Then share again so that you now share the results. Yes.
Thank you, sir.
Yeah, thank you. So scroll down. Yeah. You see, he put the difference. Total is 10. Let's see the initial where we have the p-value up now. Let's see the first. Yes. It's okay. It's okay. It's okay. It's okay. No, it's okay. You have to see that in value. The value is supposed to be, 15. And look at it now. Look at it. Sum of this 15. Can you see now? The sum of negative is 40. Sum of sum of positive is 40. Sum of negative. It doesn't really matter which one, but the one that's smaller one is the statistics. So let's go down. Where is it showing the p-value? Go down. Median. So yeah, it's okay. It's okay. There sig. Where is this sig? That is the p-value, 0.203. No, I already say it's not significant. The other one is just z. Is another person that work on and now convert that into z, but this is not, because this one is not. This is that z is the what do I call it? It's not the Wilkinson anyway. So it's not significant. The p-value is less than 0.05. No, this one is not so straightforward, but the next one we're going to do is straightforward. That one for independent. Any question? Move forward. Any question? Okay, let me share. Proceed. Now, the second group, the second group of data, Wilkinson ransom test and Whitney. Look at this data set. This data set is about substance use and depression. So you have 20 people, participants, 1 to 20. You see, the first 10, they use drug. The other one, the second 10, use alcohol. That's the type of substance they use. So they now assess their depression, Bexing depressive in inventory on Sunday. These are their score. They did it on Wednesday. This is the score. The data set the way it is, it combined two things. It combined two independent, also weights paired. So if you consider maybe either Sunday or Wednesday, any of them as the day you want to, the score you want to use, and you just, okay, this person take drug, this person take alcohol. So the people that take drug